welcome Ammar Mohanna for this podcast. This is a kind of a podcast where I'll be trying to demystify what is it to do a PhD in the field of AI. Trust me, right now there's a huge demand for AI as a subject, but doing a PhD requires a lot of efforts from your side because it's a cumbersome process of year-long experiments and trial and errors. Trust me, it's not like I just do an experiment for a day. I just have an no hope that this experiment worked and tomorrow you can do it, but it can take months, it can take years to just train a model and things like that. So now here I am with Ammar Mohanna mystifying what is it to do PhD in AI. Thank you so much, sir, for giving this podcast. I think this is going to be a lot of insight for the newcomers who are going to do their PhD.
Thank you so much, Vishwas. It is my pleasure to be here. Thank you so much for inviting me. Actually, I was looking forward for this podcast. I want to share my experience. I want to hear what others have to say about that. And I want to tell anyone who's in the pre-PhD state, wherever it was, high school, university, early or late years of university, master, wherever, it is going to be fine at the end. Believe me, I've had all the concerns. I was afraid a lot, and at the end it paid off. It seems for now that it's paying off, and at the end it paid off, but for a lot more of hard work and consistency. As you just said, it is a long years thing. So let me tell you just one simple insight here. I did tests for 6 months on something, and it worked out to be nothing. We just throw it out, and we didn't mention it at all. 6 months. So I'm gonna tell you something in research. Proving that something works is research, but proving that something doesn't work is also research, because you are telling someone else, do not try this because it doesn't work. I already went there. I went into depth, and it didn't work. So this is a mindset that I had a bit late now, after having the depression of working for 6 months for nothing. At the end, my supervisor told me that, Ammar, we did 6 months for someone else, not for us, just so that he won't try this.
Yeah, that's true. That's true. Because most of the time when we do research on anything, let me just say I'm learning something new. Probably 10 years later, it might turn out to be the dumbest technology that we are learning today, but anything can happen in the field of PhD. Like probably you might be doing a PhD today, but there'll be 10 more people who might be doing different PhDs on the same subject, but they might encounter different problems. So yes, let's just start with the questions then.
Absolutely. Who has thought that the person who discovered the math equation for convolutions, that this would be that helpful? I'm gonna just say convolutions, nothing more. I'm not gonna talk about time series. I'm not gonna talk about structured data problems. I'm just talking about convolutions. If you go into depth with convolution, you know that it is only some basic math. Basic. It's not even advanced. A 15, 16 years old could understand it if you want to make him understand it, but it's that powerful.
Yeah. Sir, I just want to ask you this one question. Like, what was your mindset when you were 15 and 20-year-old? Like, did you ever dream of doing a PhD? Because we all have that adrenal rush during that time that we will be the next billionaire, we'll be the next millionaire. But things turns out to be worse because we will now try to demystify what is life. And it turns out to be complex. And we say that let's just calm down with that adrenal rush and let's just build myself. That's the phase where you decide that you want to go for the PhD. So I want to ask you, what was your mindset during the age of 15-year-old, 20-year-old Ammar Mohanna? How was his mindset?
Okay, let me tell you something. First, I'm 24, so I'm not that away from this period. Second, let me tell you something. When I was 15, my father has PhD in electronics, and he's a professor in the university. So the mindset was there, but I wasn't sure that I wanted to go there. On the other hand, whoever want to go into PhD needs to have in mind that, this is not the path for being a billionaire or a millionaire. This is not the direct path to go there. But if you love what you do, if you love research, and if you want to discover things for the world, even minor things would help, then you would definitely need to go there. Because if you made a product that is successful, like a new type of juice, like the one who made this bottle, he sold this to me for 20 euros on Amazon, but he has money, I think, more than I do. But how satisfied is he with his life? He might have a different mindset. Maybe his joy is with collecting money. But for us researchers, educationers, academic people, even people in the industry who care about making a difference, those people are has a different mindset. Let me say, I'm not gonna judge anyone. I have my mindset. Someone else might have another thing. So when I was 15, I was like looking for, something stable, something successful but stable. Have a good amount of money, not a lot, but something good. And getting the latest tech, having everything new and being able to pay my bills. This is, a basic uh a basic hope. And in parallel, being happy. There's a famous quote: if you work in what you love, you won't need to work any day. you know but at the end, I have this mindset that I don't dream of labor. Lots of people would ask me, what is your dream job? Man, I don't have a dream job. I dream of having lots of money and living in Hawaii. But this is not realistic. So we throw this out of the window. We forget about this, and we go to real life where, okay, so what's your dream job now? Okay, knowing that I don't dream of labor, I do not like to work, as all humans naturally do. I would go for something realistic when I say, okay, so even if I don't like to work, I would work in some, because I need to pay my bills. I would work in something interesting, new, and that would make money. This was like how I chose this. So at 15, I was just choosing my curriculum. What do I want to study? I was between medicine and engineering, as most of people do, which is something I don't recommend, because I've seen lots of my friends, like a graphic designer, a friend of mine, who studied arts and then graphic design, and he's making a ton of money and he's so happy with his life. you know that's one thing. On the other hand, so I decided to go into computer and communication engineering, and I did this in between my two countries, Lebanon and France. So I did the first section here, the second section there, and when I finished, I was like, yeah, I can find a job easily. I could work in Java and Android development for the rest of my life. But do I want to do that? This pays the bills, but this won't make me happy. I love coding, I love writing codes and debugging things, but do I want to do this for 20 years? I've seen some people who are stuck in doing this and cannot go out of there. No, we can go further. We can extend our knowledge. We can make ourselves stars in our domain, not a star with the meaningful, with the shiny word. No, I'm talking about like knowing something different. We all could now go and learn Android Studio. It's not an easy thing, but we can do it. And it doesn't include lots of math and doesn't include lots of algebra. It is straightforward. It has one answer for each question. For us, if now I ask you to give me the best model for cats and dogs classification, you could not give me an answer. Nobody actually does know, because there's a lot of questions behind it. How large is your data set? Where do you get the data set from? Where do you want to deploy it? What are the intuitions behind you thinking about that? This is why I really think that it is important to know that you're not going into the easy path. Even if it has money now, even if it's really successful and it is really in demand, it is not the easy path. You know, I can tell you something, maybe going and opening a business will have you more chances of being a millionaire than this domain. But even business is not the easy path. Okay, and in our domain, I could absolutely tell you that knowing that C++, Java, and traditional programming is hard to learn and is not easy, but this path is harder. It has a lot of uncertainties. It has a lot of something that we could not answer. Nobody can answer, not even Andrew and G. Andrew and G's famous word is intuition. So intuition is having lots of answers for the same question and extracting the feeling from the question.
Yeah, that's true. That's true. Because trust me, there are ways in which people can really spin up an AWS instance or a Google Colab, can get a model, somehow copy the code from the GitHub, like we all do. I do that. I'm openly saying it. We do that. We just take the reference of Keras model. We just take the reference of what he has done, what he has not done. But when it comes to PhD, it has to be something more unique and more of your thoughts and what you said, the intuition that you need to have worked on these. So you should have had completely loved this subject and you should have had been here. So, like, I just want to ask you, like, you're from a country where there's a no great amount of literacy, like not like great amount of people are literate there. Like we have a state in our country which is called as Kerala, and it's the most literate state. Like almost of everybody knows how to write something, read something, or else they might have done some degree at least. Like a lot of nurses come out, a lot of people come up. I just want to ask you, like, what was your education process like? Of course, you told your father was in PhD in electronics and all these subjects. Of course, you should have been fascinated about electronics from your young age. Like, I want to ask you, like, what was your education all about? Because people, we still complain that our education system sucks. We do this, we don't want this education system and things like that. But I want to know your experience, the way you educated yourself.
Okay, so this is a great question, actually, and I would like to ask everyone to stop nagging about their educational system. I've seen educational systems that are very worse than the worst country you could even imagine, but there are successful people going out of there. Why? Just because the educational system gives you the ability to learn. This is what is a college degree. Teaching you how we can learn, not teaching you the material. In 10 years I'm going to be forgetting 100% of everything I learned in my university. But what I can tell you is that in the advancements and in the life going, you need to understand that it is always dependent on you, on your self-development process, on your stable learning path. I do insist on stable. For example, what I did that I finished my high school. I was loving, electronics and stuff, but my father told me that this is not the best era for electronics now. So I decided to go into computer programming, which was booming at the time. I'm talking about like 7 years from now. Okay, so computer software and software engineering was doing well. So I went into that, and during this process, I took some elective courses about AI, machine learning, data science, big data, elective stuff, so just to learn about that. And the professor who taught me the AI course was brilliant, and he made the difference for me. And he made me decide that, yeah, this is what I want to do. I want to go into something that people don't usually understand. When you go, for example, into big data, it is a great domain. It is very hard to learn. It has lots of subdomains, just like AI, but it is not concrete. It is not generic. It is concrete. That when I tell you a rule, it's a rule everywhere. Just like math. When I give you a math rule, it is going well everywhere. Just like the opposite of our case. We have some main rules, but they are not extendable. They could not be duplicated on like elsewhere. This is the case. So during my university, after taking some courses, I started hearing about Coursera, their courses, Udemy, stuff like this. So I was curious. I started taking some courses. I was applying for financial aid at the time. They gave me all the financial aid I needed back then. And I took some courses. For example, let me say machine learning course by Andrew and G, AI for Everyone course by Deep Learning AI and Andrew and G, some Udemy courses, some YouTube courses. There's lots of free stuff to learn. And I came across a book that is called, AI in Practice. It was a very generic book talking about what is AI capable of doing, what are the different types of AI. So I read the book. I liked the book. It was like the 10th book I read in my life. I'm not like a hungry reader at the time. I wasn't read that bit of a reader, and I loved the book, and I was like, yeah, that's what I want to do. So our system here makes us go into PhD just after the engineering degree if you did some sort of research. So what I did is that I did a final year project in my university where I published a paper out of it. So it was about Arabic font detection. So there are lots of fonts in the Arabic language, and we did like a detection using CNNs to detect the incoming font. We take a picture of a font and it tells us which one is which. So after doing that, we wrote a paper with it and it was published. So I was eligible for applying for a PhD position. I wasn't the best candidate because I didn't do masters, but I got lucky. That's what I can say. So my second plan was to do masters and maybe apply again for PhD because I didn't want to go into working in traditional programming and stuff like this, knowing that it is not easy. Afterwards, during my PhD, this is my second year now. I've been into 3 years in a row of non-stoppable online learning, online and books, and everything, and projects and side projects. Now I'm working on something I've never worked on, audio classification for using instruments. No one asked me to do it, but I was curious how to classify audio, and it's available on GitHub, on Kaggle, the repository of dataset, and I'm working on it. It's very cool to be able to answer a lot of questions in different domains, and I'm still learning. I took all of the deep learning AI courses, all of them. And they are not few. There's a lot of courses, and I took some IBM courses, I took some Google courses, I even went through the TensorFlow certification program, and it is like a 6 hours, 7 hours exam. I passed it. I got the certification. It was like a small milestone, and I continued over. The key for me, for as a I classify myself as a non specially smart person, is consistency. Learn and do the same thing once and again and again. The machine learning course by Andrew, I took it 2 times, 11 weeks, 2 times. I repeated the same course with the same lectures, with the same assignments, just to make sure that I do understand every bit of it. It was a bit foggy when I finished it the first time. I was like, yeah, why won't I get it again? Because everyone said that this is the best course. So if I don't take everything that is possible out of it, I didn't take the full experience. So I did again. So that was my situation, and you know, uh, I admire some people, just like I'm doing a PhD in a company here. It's called PhD, industrial PhD. So you go into the company, into the R&D department, research and development, and you collaborate with the university in order to get your degree. But you mainly work in the company. So I admire like the CEO of the company that I work in. He studies things that you wouldn't even imagine from a CEO to do. He's a multimillionaire guy. He lives in Italy on the coast. He's very rich. I wish he doesn't see this podcast, but he probably won't. But he gets really weird books. He reads about assembly coding, for example. He's a CEO. He's almost all about marketing and stuff like this and business stuff. He reads about assembly. He reads about AI. He asked me to recommend some courses and books about AI. He studies everything. He's 60 years old, man. If I'm 60, I'm gonna be probably resting with having millions of euros in my bank. But he wouldn't do that. He believes in self-development until he dies. He said that the day you stop learning is the day you die. This is his idea. And I'm not sure if I can keep this through until I'm 60, but I hope so.
Yeah, when you have some influential peoples all around you, like when you are surrounded by some great people, some influential people, they just make your mindset like, even if you are going in a very wrong way, they're just going to pull you back and say that, hey, you're not supposed to go in that way. Or else they might guide you in such a way that you are doing something wrong, but don't make this mistake once again. Simple. Like they come like a tornado and they disrupt your mindset and they go back. And that disruption is going to be there for a very long run. I just want
and
to
and
ask you
and
this. Yeah, yeah.
give me a moment. Let me tell you something here, that this surrounding could be virtual. You could make your own community of people around you virtually. You could follow the people you like and see what they learn and what they talk about, and get yourself interested in what they're interested in. This is really possible now using LinkedIn and Twitter and like other social media. You could follow the people you like, and you could like for your goal people. And then, for example, I do like Andrew Ng a lot. So what he was talking about, like this idea of model centric approach versus data centric approach, for like the month back now. He has something, a weekly newsletter called The Batch, where he expresses what he's doing in this week. So, this is a guideline for me. Every week I do I do read this batch, and I do read his posts and on LinkedIn and on Twitter. This is interesting. You are making your own community, and you are choosing the very people that you like to follow. You don't have to follow the people around you now.
Yeah, that's true. That's true. Like even anybody, like even a small child can even influence you at any given point of time.
Absolutely.
Yeah. You told a lot about your education and you told a lot about PhD, but what's the reality of doing a PhD in any subject? Like, of course you told about the reality of like you worked on like 6 months, but it was just thrown away over a fraction of seconds because it didn't even get mentioned. But you also told about the other facts also. Like, let me just demystify something more. Like, how satisfied are you doing research today, like as a PhD candidate? Because there are people who do R&D in a company, and yeah, that's a professional one, but you're doing it on an academic as well as an industrial one. So how satisfied are you? Because last time I did a podcast with somebody from BMW, and he was there doing research in BMW, and he's now a computer vision scientist. Is an amazing person. Vladimir is an amazing guy. I interviewed him and he was so good. So I just want to ask you this, like, what's the satisfaction you have by doing research as a PhD student right now?
Okay, let me tell you something. It sounds way better than it actually is, because it includes a lot of static stuff to do. Reading papers, writing reports, doing, you need to be resilient in general. You need to accept change. For example, I've heard a lot of PhD stories where the subject might change at any point of your PhD, where your supervisor might change, where the fund that you get might change. So you need to change the subject and the supervisor. This is completely okay, and you need to accept it. You need to accept a lot of changes, because this is something out of the research environment, that change is possible. And you need to stop nagging about that when it happens, because it happens a lot. And I've heard a lot of stories here in Italy, in France, and everywhere. It happens. Even in the US, in the most prestigious universities, it happens. So aside from being resilient, you need to have good spoken and written language skills in the language that you're doing your PhD in. And I'm not talking about written skill, the ones that we chat in, actual academic written skills. I thought I do know some English. For me, English is my third language after French and Arabic. So I thought that I do have some good English. I got some good results on the IELTS exam. If you know it, it's like I got 7.5 over 9, which is a good result. But I didn't have the actual academic writing skills. And I developed this. I worked on this over time. When writing a paper, when writing a report. Let me give you a general example. When you're writing a report in your PhD and you say, for example, and the results that you achieved were good, this is the worst sentence you can write, because the first question that he's going to ask you, good with comparison to what? What is good? What does good mean? You need to tell him that the result that we achieved were good regarding this paper that you cite, where they worked on XYZ and we worked on XYZ and we got a better result. This is a sentence. but you could not say good and give a full stop. In addition to what I said, resilience, good spoken and written language skills, you need to be resilient with familiar with the mindset of research and the methodology of research, because a research person who is a one who can read a lot and accept to read lots of papers and lots of journals, and accept that most of these papers and journals won't be helpful for him. you know just for me, I consider this as like general knowledge, and I go with it, and I have no problem with it. I just go and say that, yeah, that's okay, I have no problem with it. I'm gonna read it even if it doesn't make any good any direct good influence for me. I go with that. So those are, resilience, spoken and written skills, getting familiar with the research mindset and methodology, and having maybe some research background would be great. Those stuff are the soft skills that you need, you know, but those soft skills are like the key to the word of research. Because in addition to the soft skills, you absolutely need a lot of hard skills, let me say, technical skills. So yeah, that's what I can see from my perspective. I'm not that uh you know I'm not that happy with research, like with comparison to where I was before applying, but it's good, it's really good. And for me, I'm taking the best of both worlds of academia and the industry. I'm seeing both, but this is overwhelming sometimes for me, because there's a lot of contrast between them. Like this, I have two supervisors, one from the university and one from the company, and they both want me to do things, and I'm in between trying to interpolate their point of views and come up with one thing to do. And this is exhaustive, it is time consuming, it is overwhelming sometimes for you, because I'm not in my country, I don't speak the language, the Italian language. I do speak Italian, but not very well. I do speak some Italian, but I cannot discuss stuff with them. They are both older than me, way older than me, so I cannot intervene at every point of time. I need to sometimes just listen and maybe interpolate the point of views and get to a similar result. Otherwise, I would need to work on two directories, and it happened during the 6 month of searching for something. You know, yeah, this is normal, and you need to accept it as a part of resilience.
Yeah, last time when we were supposed to record, you were there in Africa, and afterwards, we didn't get a chance actually to record because you were busy during that time. So, like, let's just say, what's the field work like when you are a student, when you are a professional right now? So, what is that field work all about when you are doing a PhD? Like, of course, when you are in the industry, it's a different story. You will be discussing with the clients, you'll be getting to know their problem statement, and you will be solving it. But like, how is the field work here?
Okay, so mainly when you're in the research, you are trying to prove something. Okay, so first you want to come up with something to work on. For example, let's say CNNs and a certain model, a certain problem that you are trying to solve and get better accuracy on. So when you do that, let me give you an example. Here in the University of Geneva, they are working on a prosthetic hand that can sense, that can give you back the sensation of touch, even after deploying, the artificial hand for the ones who had their hands cut in for a certain reason. So they have a mesh of sensors on the hand, very small sensors, and they give stimulation on the biceps. So what happens in here is that they collect this data out of sensors, and they try to learn how this data is meaningful. For example, touching a surface that is rigid is different from touching a surface that is not. Touching a keyboard is different than touching a mouse. So they are trying to make all the classes of life and differentiate between them and give them a different stimulation. So this is what they are working on, and it is, mind compulsive, and it's really hard to think how hard their lives is. But at the end of the day, they need to understand that after 6 o'clock in the afternoon, they need to stop all of that, stop thinking. And sometimes it doesn't work out. let me tell you something. Yesterday at night, I had a lot of things to do today. Like I had like 6 tasks, and I was willing to go to sleep early, 11 o'clock in the evening, and I slept at 2 last time at the clock. I was just thinking and thinking and thinking, you know, I'm gonna do this and then go back for there and have my breakfast and have my coffee, and then I'm gonna do this and that, and coordinating lots of things. And if you see my Google Calendar now, it's a mess. It's a complete mess, filled with tasks and things that move before and after, and you move things to the other day and the day before, just to be able to do things. I wouldn't imagine myself doing this, but sometimes on the bus, I open my laptop and start, writing something, modifying the task, doing something. I this is something that has changed a lot in my personality as as a researcher. You need to change towards this.
Yeah, but what's the nature of the problem statement that you will be seeing when you're a PhD researcher? Because not all problem statements are cats and dogs, not all problem statements will be the same breast cancer or the cancer patient's data set or something like that. So, what's the nature of the problem statement that we should be ready for?
Okay, so don't be overwhelmed. I'm gonna explain my own problem, and it is overwhelming. I like, this is a spoiler alert. It is overwhelming. Don't to think about it. So what we are trying to do, we are doing a maritime application in the sea on boats, like big boats, where you have lots of sensors. For example, video cameras, picture cameras. You have like infrared sensors. You have like flame sensors. You have like a life jet, a life vest for each person, a smartwatch on their hands. You are having lots of data, structured, unstructured, everything, and you need to take a decision following this data whether you want to call the help or not. So this is inspired by an accident that happened on a ship, and the help was late for like 30 minutes, and because of those 30 minutes 20 people died. So they are trying to solve this using AI. How would they solve this? I'm gonna give you like a brief example. If the temperature in the engine room went high and the heartbeats of the workers in there went high, you should call the help. And what type of help? This is dependent. So in this case, you need to go, the fire people. Other example, if the weather was foggy and the heartbeats of the captain went high, you should know that they need help. Okay, so this is my project. You could extend it as much as you want. I'm gonna give you like an easy way to think about that. You just think of it just like this. You have video input, you have pictures input, you have like 10 types of sensors all across the ship, in different rooms, in hallways, outside, inside. You have weather sensors, you have temperature sensors, lux meters, the one that measures how much light is there. You have sound sensors, you have steps sensors, you have heartbeat sensors, blood pressure, everything. And you need to coordinate all this data into one decision. Even people with having all this data in front of them could not decide. So we are trying to make something that exceeds the human level performance by far. So let me give you an example. For now, we achieved like a 72% of accuracy with all the constraints of actual accuracy. A human could give you 11%. So with the human level performance is 11%. So for now, if we only got to 70%, we did something really well, because we exceeded the human level performance 7 times. This is the type of problems you're gonna be facing, but it depends on the application, on lots of different things. But yeah, this is a type of problem, and it is solvable when you defrost it.
Yeah, last question. I just want to ask you this question because I and you and other people who really care a lot about edge computing, right? I just want to ask you this one question, like, what's the nature of the compute that we are going to see tomorrow? There is an advent of medicine and AI and computers today. There is cloud computing. There are different technologies which will improving over the course of time. But what's the nature of the computers tomorrow? Because we are trying to like put in a lot of intelligence on an edge, like a very tiny device, lot and lot of intelligence just put in. Like, what's the nature of compute tomorrow?
Okay, so first of all, I don't know. I don't have a complete answer for this. I can give you some examples so that you get the intuition behind it. So first, I can tell you that a Raspberry Pi, very simple Raspberry Pi, very cheap, is able to infer very, very, very big models using TensorFlow Lite. That's our first step. The second step is that we are looking into federated stuff. Just like, I have 10 sensors here that mean something and 5 sensors here that mean something else. I don't need to send all the data in. I just need to make a decision here, make a decision there, and then combining both decisions to make the bigger decision. And this could be the cloud. So we are here talking about a hybrid combination between the cloud and the edge. And if your application works well on the edge alone, that's super great. You won't some needs of privacy would ask you not to send data on the cloud, some privacy restrictions and stuff. So this is helpful here. And even the edge isn't always, a small chip. It could be a server. That's an edge. But when it's not connected to the internet, it's called also edge. So when you're running something on your desktop, on your laptop, without the intervention of the internet, you are doing something on the edge. But it depends on the edge. How edge is it? How edgy is it? And does it work alone? Does it need assistance all the time? And the greatest problem with edge computing is apparently, as it's super easy to tell, the computational power and the power consumption. So here you are going into a different field. You need to measure the power consumption of something and use less neurons in order to fit on this, computational limited resources, and to use less power in order to maintain a battery life that is longer. For example, in the life jackets, we implemented something in which the battery could last 7 years. Maybe I used, not only me, we used 30 neurons, but they were necessary. 30 neurons, this is the number, including input and output neurons. So yeah, this is what you need to work on. This is what you need to consider, like solving. This is the type of problems.
Thank you so much for this wonderful podcast. I think it covered a lot and lot of insight. I think the people who are going to think that they are going to jump in for the PhD program right after their bachelor's or something, I think probably this podcast is going to be the first step to get to know what's the pros and the cons of getting inside PhD. And thank you so much for this amazing podcast, sir.
It is my pleasure. Thank you so much. And please don't hesitate contacting me or yourself. Don't be shy. Just, go into the direct messaging and ask for any possible question you would have in mind. If I don't have the question, I would direct you for someone else who does have the question. And if he doesn't, he could help. The collective work these days is getting more and more, grown up. So it is super normal to contact anyone online. And what's the worst thing he can do? Not answer you. No problem. Just ask for help. No problem.
Yeah, that's true. Thank you so much, folks. Anytime, contact me on LinkedIn, Twitter, Instagram, any place that you find me, just contact me back. But I have to be authorized for it also. Yeah. Thank you so much, sir. Thank you
Absolutely.
so much.